Next, let's introduce you the joint distribution of x and y. Joint distribution, that means it's a distribution of two variable or more variables. Okay? In our example, the two variables of interest, they are gender, which we call x, and promotion status, which we call y. Okay? Possible value for gender, male, female. And possible value for promotion status, yes and no. So, when we say joint distribution of x and y, how many possible values we actually have? We have what? 4 possible values. And they are male, yes, male, no. Female, yes, and female, no. How many male workers in the last 3 years got promoted? Well, there were what? 300 what? Such peoples. And how many male workers did not get promotion in the last 3 years? Well, there were what? 200 people in these categories. Same thing for female, yes, 100 people. Female, no, 400 people. So indeed, from this table, you can see the possible value of gender and promotion status as a combination. And how many what? How many people fall in each of these 4 categories? Okay? Now, a two-way table has 2 marginal distribution. One for common variable x, which we call gender, and one for the low variable y, which call what? We call promotion status. Now let's take a close look about the marginal distribution of x and y. Marginal distribution of x. Okay? X has 2 possible values, male and female. Male and female. Now, these are the possible value of x. How often or how likely we see them? Well, 500 people in the company, they were male. And 500 what? Female worker, they were in the company. Okay, so possible value, male, female. And how often you see them? 500 and 500. So this one is a marginal distribution of x. And next one, let's look at the marginal distribution of y. Next one, let's look at the marginal distribution of y. Marginal distribution of y, what are the possible value of y? Well, yes and no. Yes or no. How many people got promoted in the last 3 years? There were 400 people got promoted in the company in the last 3 years. And how many of them did not get promoted? Well, 600. 600 of workers in the company did not get any promotion in the last 3 years. So yes or no, these two are the possible value. And how often we see them? Yes, 400. No, 600. Okay? Now, alternative representation for a two-way table. Remember, when we say distribution, there are 2 information need to be specified. One is the possible values. The second one is we need to tell people how often or how likely we see them. The first representation we deal with how often. And the alternative representation we deal with what? How likely. How likely is a percentage. How likely is a percentage. For example, we have 300 male workers. They got promoted in the last 3 years. 300 divided by total number of workers in the company, 1,000. 300 divided by 1,000, that is what? That is 30%. So another way to represent the joint distribution of a two-way table is we use percentage. Okay, we use percentage. This one is 300 divided by 1,000, that is 30%. This one is 100 divided by 1,000, which is 10%. This one is 200 divided by 1,000, which is 20%. This one is 400 divided by 1,000, which is 40%. Same thing for the two marginal distribution. The gender, possible value of gender, male, female. Possible value for gender, male, female. But how likely you're gonna see a male worker? 50%, which is 500 divided by 1,000. How likely gonna see a female worker? 50%. That is 500 divided by what? 1,000. Similarly, we can apply to promotion status. Okay? So this is alternative representation of a two-way table. Now, next, we're going to define two terminologies. First one, we call response variable. Response variable in our textbook, it use what? Dependent variable, or the abbreviation, DV. A response variable measure an outcome of a study. An explanatory variable, or we call independent variable in your textbook. The abbreviation IV. Okay? And how we define an explanatory variable? An independent variable explains or causes change in the response variable.